Hey everyone, I hope you are all doing well, and welcome to this new video where we are again looking at OpenAI Codex, but in my previous videos where we've been sort of testing it on these toy problems, well this time we're switching that up and we're going to test it on an actual problem. So if you are not aware of what OpenAI Codex is it's essentially a model that generates code, and I'll show that and demonstrate that in a second. But if we quickly pop over to this tab, you can see that there is this Kaggle competition going on. It's hosted by Google Brain, and it has to do with predicting ventilator pressure. So they have this sort of artificial lung, and they also have a ventilator they are using with it. And with that, they are recording some data and then trying to predict, I guess, the pressure that's in the lung or something. So you probably don't pop it. It's something like that, right? Maybe not exactly right, but something along those lines. And I want to apply Codex to this problem because in my past videos, we've seen some impressive results, but we haven't seen actual use cases of where this could actually be used. So this is going to be a bit of I use OpenAI Codex to do the vast majority of the work, but as a programmer and like an ML person, right, I can also kind of guide it in the right direction. So this is going to be probably as close as you can get to a real use case of Codex. Hopefully we'll see. So if you look at the competition here, they sort of talk about this. They have some data that I have already downloaded in advance, and they describe the data here. And then they also have a leaderboard. There's actually a lot of people working on this challenge. I think it's like over 1,500. So quite a fair number of people. So this is a real and important problem. So if we go back to the data section here, they sort of provide a bunch of details about what all this data looks like and stuff. I've actually prepared in advance just a little bit by mostly copying this over to Codex. Even from the future here, quick note, I forgot to mention that we will actually be making a submission to this competition before the end of the video, and I'll let you all know so you can all see how Codex actually performs in comparison to other people. So that will certainly be interesting to see. We're about to jump into the code. Last thing before that though is if you do like this type of content, do consider subscribing to the channel. I still run a very small channel, so every one of you that subscribes and likes the video and hits the bell icon really helps out a lot. So thank you so much. Let's jump into the code. So I have this sort of thing I've set up, and I've essentially summarized what the data is about. I've copied over what the files and what the columns in the dataset are, and I've done this just to save us a little bit of time. So the goal here will essentially be to give as much freedom to Codex as we can, while still guiding it and doing our best to make sure it comes up with the best result. So I want to start this out by, we have all this sort of this context. And then at the very bottom here, I put below we outline steps in the program and how the model works. So what I want Codex to do is start out by generating its own approach. Now, I'm not sure if this will work very well, and if after a few tries it doesn't, maybe I'll go ahead and put in my general steps for what I would do, but I want to give it a chance first. So let's go ahead and click submit, and we'll be able to see it start generating some steps. Okay, so let's see what it has. Oh gosh, oh no, that's more than I need. Okay, there we go. So load the data from the CSV files. That's good. Pre-process the data. That's also good. Create a model, train a model, test the model. Okay. That's all right, and output the results. So these are all good. This is quite general though, right? Like this is kind of what you would do with almost anything. They're also using TensorFlow. I don't really want to use TensorFlow because I totally forgot how TensorFlow works. What I do want to do is I want to make this a little bit more detailed. So I'm wondering if we can try and have it specify what type of model this is going to be. So create a model. The model is let's see, the model uses, and see what it comes up with. The model uses, okay, a LSTM with a dense layer to predict the airway pressure. Okay, awesome. So this is good. I'm okay with this. I'm not sure an LSTM will be the best thing here, but it's certainly a good thing to start with because the data gives us essentially, it's time series data, right? So we get information about how much, I guess, about like the pathways of the airway going in and it coming out and all that sort of stuff. So an LSTM is a good natural choice here. So the next thing is to train the model and then test the model. I'm going to output what it had before. I'm going to put back in what it had before, which is output the results as a submission file. Okay, so one last thing I want to do before we have it generate more is specify that this should be using PyTorch because I know PyTorch. So we want it to work with PyTorch. So right here, we can say we create a SOTA model. And I'm going to put SOTA here, right? Like state of the art. This might seem ridiculous, but this is my naive approach at prompt engineering, I guess, because what Codex is trying to do is it's trying to predict the next character, right? So if I say that this is a SOTA model, it will be hopefully more likely to output code that would be seeded a SOTA model. That's the idea, but I don't know how long this will work. So let's say we create a SOTA model in PyTorch. Cool. So hopefully we should be using PyTorch now. This is one thing to note is that it's generating code now, but I actually have a very long context, as you noticed. I put in a lot of data, so I am curious of how well it will remember all these details. Like here, you'll see it has ranges. I wonder if it will actually remember those. I really don't know. So we've done some importing though, so this is good. We've imported a standard scaler, so that's good. Loads up the data, so reads from the data directory, which I had specified in the context, so that's correct. The train and test CSVs, awesome. Then pre-process the data, so let's let it generate a little bit more and see what happens. Standardize the data, convert it into a PyTorch tensor. Oh gosh, I really have no clue if this is gonna work or not. This is a little bit spooky. You know what I'm gonna do is I'll be right back. I actually wanna plug this into a Jupyter notebook and see if this is working as we go, so I know if I need to adjust it as we go. So give me 1 second and I'll be right back. There we go. As you can see, I've copied over all the code into this Python notebook here in Visual Studio, and I've been testing it a little bit. Now you might notice I've made some slight changes. So if we go back and we look at the original code real quick, you can see that it's grouping these into essentially groups of 200 rows per example. Now, as it turns out, that actually is an issue because I did a little testing and I didn't specify this, so I guess the model couldn't have, or Codex couldn't have known, but really these comes in groups of 80. So I changed the 200 to 80 to help it out a little bit. As I said, I am going to be slightly hands-on here to help this out if it's, something minor like that. So let's go back over to, this is what I have here. So this last line here though is a bit of an issue. So this train val, it's essentially splitting up the data into training and evaluation data. That's not an issue. The issue is that it's randomizing the order. And because this is sequential data, well, we can't just be randomizing the order without regard for that. So what I'm going to do is I'm going to delete back up to that point. And I should show you a quick example of, before that, this is what the data looks like, right? So you can see essentially what it did in the last step was it created this, I don't see it here, but if we maybe do this one more time, it created this. Oh, time, yes. So time is what it created, and time is essentially the index in this specific example. So it's kind of working. So let's delete up to this random, or delete back to this randomization part. Let's see. So split each example into train and test set, where the test set is used to make predictions for the submission file, except for that is not true because we already have the test, right? So rather we want to split the example into maybe we can just get rid of this entirely. Let's try regenerating and seeing what it comes up with this time around. I'm going to go ahead and turn up the temperature a little bit. And the reason why is because we want more varied responses. We want to try and generate something else. So let's see if we get something different. We turned it up a little bit. Maybe it's still too low. Yeah, we're still getting this. And again, the issue is that, so maybe we can reword this comment right here, and maybe that will help it out. So now that we've specified that, let's try rerunning this and seeing if we get something different this time. Okay, so it just doesn't shuffle this time, that works, right? So it's just instead of, it's doing the same thing without the randomization. I will take it. So next it makes a standard scaler, which is good. We're going to need to scale the data because it is all on different scales, and we're using a neural network, and neural networks tend to work a lot better when you do either normalize your data or do some sort of normalization. I wonder if it's a good idea to change the time step column. We probably don't want to do that. What we can do to maybe help this is specify which of the columns we want to use for training and which ones we want to normalize. There we go. So I have typed out the columns that need to be normalized and specifically noted that pressure is the target column, or what we're trying to predict. So let's delete this and try redoing this now and see if we get to the right columns. Okay, so it fits on the training data for RC, U in, and U out. That's good. That's what I had right here. And then it transforms each of them to be the new values. And then it also fits on pressure, a different scalar. And then I guess it does the same thing, except for it doesn't do it for the test because it's not in the test, which is good because I think I did write that, but it was way up here before. It was somewhere up here. So I'm kind of impressed that it kept that information. I guess I did write that it's the target right here, so maybe it could be implied that it's not in the testing set. But either way, this looks good. What I'm not sure about, though, is each of these values should be normalized like separately, right? The values of R and C should not be combined together and then normalized. Each one should be normalized separately. I'm not sure if that's happening. So what we can do is we can copy it over to Visual Studio and give that a test to find out. I've copied the code over here, so now these lines should scale this data appropriately. Hopefully it works. So if we do train.describe, we should be able to see some descriptions of this data, or a description. So if we look at the mean in these specific columns, so R, C, U in, and U out, we can see that all of these are very, very, very small numbers close to 0, which is exactly what we were hoping to see. That means that each column is being scaled separately. We can also see the standard deviation on each of them is 1, which is exactly what we were expecting. So that is super awesome. I've also gone ahead and copied the code over to, I have like a different notebook for testing and a different one that will be used for our final generation. So just note, I am kind of switching between those. So hopefully that is not too confusing. Now, if we come back over here, we should be able to just keep generating. This is doing pretty good so far. So let's go ahead and generate a bit more. Here, I forgot to switch this to 80, where it said 200 per row. So let me switch that. It looks like it's messed up, so 79. Okay, so we're converting these into tensors. That's good. Then create a model. Okay, so let's see what it does for creating the model. I'm not going to read all of this, but we can look at the code and see if it looks roughly right. So it's creating an LSTM cell, and there's some input size. Okay. I'm not sure if this is right or not, but it looks roughly like it could be right. So let's generate a little bit more, and then we will run this to see and make sure we don't get any crashing. So we'll take this, and I'm copying it over here. Let's run this. That looks good. So now let's go down here and copy up our model, and hopefully the model runs without error. This doesn't necessarily mean that it's just because I ran it twice. So now if we come over here and we paste in our model, let's make sure that this runs without any issues. Now I should say, just because it does run without any issues doesn't mean that it's necessarily correct, but it's a good sign nevertheless. So let's go ahead and generate some more, I guess. It might be a good idea to look over this, but honestly, I'm a little bit lazy. We'll figure out if it works soon enough. So, okay, so it's generating some more training. So it's printing out the loss, I guess, and then this is for evaluation. It looks like it's doing a whole eval loop, which is good. We want to do some evaluation so we know how we're doing, and then the training is complete. So let's actually generate a little bit more. Ideally, I don't like to generate so much at once, but I kind of want to give it the opportunity to do this. Then maybe we can go back in with like GitHub Copilot and fix individual lines at a time or something. I'm not sure, but let's see. So output. Wow, it sure does love generating all of these. Here we go. And I think that's the end of the program. So if I try and submit more, yep, it will not generate anymore. So it looks like this is it. We should be able to run these two things, right? Because we've defined the model and we've created this train function. The test and the output we've not copied in yet, but let's go ahead and try these out. So this should, maybe we want to try and create the model first just by itself to see if that gives us any errors. Hopefully it doesn't, but let's see. Okay, the model was created. That is great. So next we can go down here and we can see if it will train, and it does not because we have an error. So what's the error? Object of type function has no length. What could be going on here? I'm back and I found the issue. It's actually a funny little issue. So if you remember up here, this had originally been named train. The data we were using was named train, and the function to train is also called train. So this train function was overwriting our data. So I went and I changed this to train data. So that little fix should hopefully fix that issue, but let's see if this works. After that, I need to create the model. Now let's see if it works. Okay, so we're still running into an issue. Too many values to unpack. So what this must mean is that this train loader, we're trying to get inputs and targets out of it, but it must only have one value in it. So like just the inputs or something. So I'm gonna go ahead and fix that, and then I'll be right back once that is also fixed. I'm back, and I have not actually fixed the issue yet, but that's because I noticed another problem while I was going through this. And that is that if you noticed earlier, here we have our train values and all this stuff right here, right? Well, when we're converting this to tensors, The issue is that we're actually taking all the columns of our data, which is not actually what we want. What we really want is we want specifically the columns that we're using for training plus this pressure column that we're using as the target. So what we really should be doing is taking those and then converting these into tensors. And then here we can put it in this, I guess, this data format that it wants below, where it's trying to get the inputs and the targets. So I don't actually want to write this all out by hand because I want to see if Codex can kind of fix this up a little bit. So what I will be doing is in line, I will be using GitHub Copilot, which is, as you'll see here, it's just sort of, I guess it's the same thing, right? It's using Codex to power suggestions. So I'll be using these to fix this. So let me go ahead and write some comments as to what I want here, and then I'll be back and we can test this out in line. Okay, so we've got this here now. I'm actually going to go back to here and we're going to hit submit and see if this will give us anything, because clearly it was having trouble earlier. So it looks like it's about right. Let's go ahead and let it generate a little bit more. Okay, so it does the same thing for the value in the test, and it goes back into the model. So let's copy and paste this back into our code. I guess there really is actually a difference probably in the models they use between the AI Codex and the GitHub Copilot that's here, and maybe that's why it was not generating things. Or maybe they use it a little bit differently. I'm not quite certain, but it's interesting to note. So we've got that, and now what we can do is I'm actually going to copy and paste this back into our, so I'm using so many files here, but it's not super easy to generate this, or it's not that bad, I guess. And let's run this and see what happens. Function is not subscriptable. That is, again, because we have the train function, where what we want to be doing is say we need these. I'm going to convert these into data. I'm going to reformat this just to make this a bit easier. You know, what I've actually just decided to do is I've copied and pasted our model in here, and I'm just going to regenerate this training loop, because now that we've changed the input data, we probably need to be able to redo this. And it looks like it's actually doing it much simpler this time, which is a bit nice. It's not making different functions, which I mean is generally nice, but for the purposes of this video, it's probably best to not do that. So let's copy and paste what we have over here into our code, and we will see if it works. So going back to Visual Studio, I'm going to delete all our train loops. Very sad, but it has to be done. We can delete all this. And let's see, so we create a model. I'm going to put that in its own cell. We already know that works though, so that's great. Or if I run them in sequence, it works. And then here we create a loss function, and let's see, so for in range of epochs, so I'm going to change this to 10 epochs, because, you know, 100's quite a while, and I need to finish this video at some point. So forward pass, it puts in the train input, and it gets the output pred, and then it does a MSE loss on them. I don't actually know if this is going to work because I haven't used LSTMs in a while, but let's run and give it a go. It hasn't crashed yet. That's a good start. It's definitely a good start, and I'm hoping for the best. It looks like we unfortunately got an error, and I've noticed a few things because of this. So the first thing that is actually causing the error, we can see the input size is this, then we have an 80 sequence length and 4 input features, and we are also for some reason outputting 4 features. So if we go up here, we can see that in the model, the out features is equal to the input size. Really, let's just change that to 1. It's not a huge change, so I don't mind making that change by myself. And that should give us 1 output. Now, another issue is that it's taking all 75,000 examples and kind of throwing them in at once, which technically would work. For the purpose of this video, though, that makes this very slow, which is not ideal. So what I want to do is try and put this on the GPU, which, you know, I'll excuse Codex for not doing that because I didn't specify that. So I'm going to go ahead and move this to the GPU real quick and do a little testing to see if I can get this faster for the video, and then hopefully I'll run this again and hopefully we'll get it working. Okay, I am back, and unfortunately we got another error because, as I kind of expected, throwing 75,000 examples through the model at once did kind of overload it on memory. So I'm going to copy over my changes to the codex, and then from there, what we're going to do is we are going to try and regenerate it to do batches of data instead of just throwing everything at it at once like an absolute madman. We'll say train the model in batches. Now we can say the number of epochs is 10 and the batch size equals something like 128. And once we've got that, let's go ahead and regenerate, which is kind of sad because it looked like the last one might have actually worked, but I bet it will generate another thing that works. So hopefully we should be good to go. So it looks like we've got some sort of training function here. And it's not too complicated again, so that is very nice. It looks like it's just doing a selection. Now we can copy all of this in. And I am just now noticing that we probably also don't want to put all this on CUDA at once. So instead what we will do is, where is it? So batch input, we'll put dot to device. So we will just, we'll just do this as we go. Then it thinks we have a loss function, but we don't. Why is that? Did I forget to copy something? I did, I forgot to copy this. Oh my, oh my, so careless of me. So let's copy that up here. Okay, I did a quick reset. Let's hope for the best. Okay, that is not great. The size of tensor A, 80, must match the size of tensor B, 128. So it looks like we have a dimension mismatch going on here in the loss function specifically. I'm back, found a quick little error. We just needed to have a 1 in the outputs. It was expecting, it was just a simple dimension mismatch, nothing too complicated. I also averaged the losses, so when it will eventually print out the losses here, it should average over them. Just a little thing to help out with the video, nothing big. Let's run it, and it works, except for I'm printing something out that I don't want to be printing, so let's fix that. I'm actually amazed we've gotten to this point. Hopefully it actually works. I guess it just might not work at all. So that would be a shame, but it's running. So let's give it a few seconds, and once we get, oh no, we've already got an output. So the first loss is 0.5879. Nice. Okay, so let's give it another second for the next epoch and see if that goes down. It did go down a little bit, so I'll give it a little bit of time, and once we get to the end of this, I will let you all know. Okay, we've gotten to the end of it, and the loss was going down the whole time. So it looks like something is being learned, probably, so that's great. The issue, though, is that we don't have the validation loss yet. Now, I think if we go back to the Codex playground, it was starting to generate it here, but really what I want to see is I want to see constant updates of how this model is doing on the value, the evaluation data set as we go. So I'm going to delete this part, and I'm going to add a variable called something like log frequency. And we will set this to, I don't know, something like 50 to start out. And in this loop, we are going to say calculate the, what is the evaluation loss. Calculate and print. And hopefully it should do that and continue just as it was doing before. This looks about right. So I want to, of course, test this. We should also be printing out the normal loss too. You know, I really, here, this should be a quick little fix. We'll do np dot mean losses negative log frequency. So all this should do is print out the losses, which is great. Train input divided by batch size. So let's take this and copy this back in and see if we're getting what we expect. Now I am actually, this is quite a long line. Log frequency. Well, oh well. I'm going to change the log frequency to like something very small, like 5, and that way we can actually test this out and see how it's doing before we figure out that it's not working at all or something. Okay, that looks good. Now it looks like the validation loss is 0 though, and that is not great. So why could that be? The validation loss, so let's see, the validation loss is the last thing that it is printing out. And when it is printing it out, it's printing out val loss dot item. Interesting. I wonder what's happening there. I actually have no clue. It's checking val output with val output. Well, of course, it with itself has a loss of 0 because it is going to be the exact same as itself. So instead, this should be val, I'll call it preds for prediction, and put that, I believe it goes right here. Now if we run this, we're going to get an error because we have not put these on the, this is a very inefficient way of doing this, but you know, it will be fine. Still an issue. Still an issue. It says, oh, it was supposed to go right here, my bad. And there we go. And we get the validation loss, which is going down very rapidly. So that's great. Last thing we'll want to do is change the log frequency to something greater like that. And we'll just try it 5 epochs. And I'm going to run this. And as soon as we have the results, I will get back with all of you. So see you all soon. Oh, there's a little error here, but you know, it's fine. I'll fix it in the break while I'm gone. The model is not quite done training yet, but I wanted to make a quick update because I noticed that the hidden size of the model before was 32. I went ahead and changed that to 128 just because, we might as well try a little bigger model if we can, 32 is pretty small, might as well spice it up a bit. And then the other thing I did is I noticed the model was not specifying model.train and model.eval. This should improve our performance a small bit. So I thought I just added in, not a huge thing, but the AI Codex did miss that. So I'll be back again once this is actually done training. Okay, I am back, and I actually cut the training process off a little bit early because it looks like our loss, we weren't really able to go so far beyond 0.5, but that is totally okay. That is still, it's kind of hard to say exactly how good that is, but that is why we will be doing a submission. So that's the final thing we're going to do is we are going to have Codex make a submission to the leaderboard. So let's go over to Codex, and we will, let's see what we have here. Test the model. So let's paste this in here. It's just the update. And now we will say run the test input. Run the test input through the model to generate a submission. And hit submit. And hopefully that works. I don't know if I specified how this submission should be formatted, but hopefully I did. I guess we let this keep going. Test predictions. Oh no, it's gotten into an infinite loop. Let me look up the format for what this is supposed to be and specify the format so it has an easier time doing that. Let me check that real quick. Here we have a sample submission. So what you can see is that it's just the ID on the left, and then on the right you have a column for pressure with the pressure. So if we go back here and we can specify, run these to make a submission file, then we can say the format of the submission file is, I guess we can say a data frame with 2 columns, ID and pressure. The ID should be taken from the original test data. And now, hopefully, this will be able to generate something a little bit better. Oh, there we go. ID equals test ID test. I guess that's back from our test data. Did it not? Didn't we change that to be test data, test input? Then I guess we just have test. Yeah. Okay, so it should be test. So test ID, and then it has the pressures, and it just reshapes it as -1. I think as long as it didn't randomize the order, this should be correct. Maybe I should double check because I don't want to submit something just for it to all be wrong. But yeah, it doesn't look like we are randomizing anything anywhere. So hopefully that should be it, as long as we don't run out of memory, which honestly I think we might while running this, but I guess we are about to find out. Let's go ahead and give it a go. Will it work? Will it work? If it does work, I'm going to be very happy. Very happy. Oh, okay. We have a submission file. And it looks to me like this is exactly what we were looking for. However, there's a catch here. Codex forgot something, and it forgot that we normalized our data. So we are going to need to unnormalize it. Thank God I remembered that, or I would be very sad thinking that this didn't work at all at the end of the day. So I almost forgot. That is a close one. So we have our test preds. We can just put a comment in here to say unscale the predictions. There we go. That inverse transform, scalar.inverse transform. I didn't even know that was a thing. Well, maybe it's not, but hopefully it is. If it is, that's really cool. Let's take this down to over here. Oop. And, oh look, I was just going to add this fix and it actually has it itself when I delete it. I wonder why it didn't get it the first time. But that, I think, should be all we need. And that should get us our submission. So let's give that a go. Oh, you know what? I need to regenerate these because let's rerun this one more time. And then we should actually be to the end of this now. Awesome, so that ran. Let's look at our submission, and it looks like these numbers are a lot different now. And yeah, I mean, I think this looks like hopefully what we're looking for. this is roughly the right range of numbers. I did a quick little check before this. So I'm going to go ahead and submit this. And I guess really we just have to hope for the best. I'm actually really curious to see how this turned out. I'm not expecting any medals here, but maybe if we're not in last place, I'll be quite happy. Let's head on over to here and submit predictions. Then all we have to do is open up our prediction and drag it in here. So where are we? Down here. Drag over the submission.csv and let that go. Okay, it finished and we have a 6.39. Now, you probably don't have much context, so you don't know how good or bad that is. As it turns out, if we look at the leaderboards, a 6.39 is very, very bad. A 6.39 puts us in 1,618th place, which is, we're in the bottom, what is that, bottom 80? I guess we're not in last place. So that's better than nothing. But yeah, this is a terrible score. It's slightly disappointing, but I guess the code ran. I'm really wondering what went wrong, so I might take a second to actually look over the code myself and see if I can catch some, like anything obvious, you know. And if I do, I want to let you all know. So I'm going to do that real quick. I'll do a last quick search, and if I find anything, I'll retrain it and resubmit. I made some changes, looked around, and I made one last submission just to make sure. We ended up with a worse score, so it looks like there probably is a problem with it. I am calling it right now. As soon as I upload this video, someone is going to look at this video and they're going to be like, Eden, how did you not catch this super stupid error on line X? And I'm going to be like, oh my gosh, I can't believe I didn't catch that. So if you do see the error, do let me know. I'll fix it, make a new submission, and then I will upload what the score was once I fixed it, if there is actually something like that. But either way, it was interesting to see what OpenAI Codex was capable of when it came to an actual problem. I personally I'm not sure I would have used an LSTM on this. It's definitely not a bad option. Maybe some feature engineering would help here. I've seen some other people do that for this competition. Or maybe there was just a blatant error that I didn't catch. But anyway, I hope you found this interesting. If you do like this sort of thing, consider subscribing to the channel. I'm a small channel, and every one of you that goes and hits the subscribe button, likes the video, and hits the bell icon, it really helps out a lot. But anyway, thank you so much. That's it, and I hope to catch you next time.